So to continue with part 3, we were trying to answer this question about the function f of xy equals xy over x squared plus y squared. And the question is, what are all the possible limiting values? Like, what kinds of limits can you get? What kinds of z values can you get for straight line approaches of the form y equals mx? And the hint is, substitute y equals mx in order to determine the limiting value as a function of m. Now plot that function as a function of m from -10 to 10 and see what kinds of values you get. All right, so let's just copy paste this down below so we have our eyes on that function. So here's our function we're working with. And we want to substitute, let me just make a little space here. We want to substitute y equals mx into f of xy. All right, so instead of y, I'm looking at m times x. I could write that better, right? We could write m times x squared. Okay, that looks better. And then in the denominator, x squared plus y squared, again, if y equals mx, this would be an m times x all squared. We can write this better. We could just say it's an x squared plus an m squared x squared, or factoring out the x squared, we could say it's 1 plus m squared. And let me fix that. There we go. Okay, so that's our function. Let's define this as a function of m. Shift enter. Notice that the variable is in green. It's our m value. So this is a function of m. And now let's plot. And we're going to do this as a function of m as m goes from -10 to 10. So these are the sorts of limit values we could get. And I'm going to let you think about that for a little bit and to just kind of reference a few things. For example, up here, when m equals 1, we did the limit and we computed it to be 1/2. So in this plot, when m equals 1, there's m. When m equals 1, the limit was 1/2. And then for different values of m, like m equals 5, you get different limit values. So the challenge for you is to interpret this plot in the context of this question. Answer the following questions. Okay, you may need some techniques from Calculus 1. You can do that. And then exercise 3 asks you to plot a function. Consider the limit as xy goes to 0, 0. And then the last thing is we want to think about continuity. And certainly this function is not continuous at 0, 0 because that would put a 0 in our denominator. So it's not defined at 0, 0. The question is, what should we define it so that f is continuous? And if you need a hint here, your hint would be to go back to Calc 1, notes or book. We have the book. For functions which have a removable discontinuity. Okay, you could do a Google search for that as well.